My name is Imam Frank, your regular tutor. We are still in our series of mathematics lectures. In this package, I'm going to look at coordinate geometry. But before we start, let's look at the format of the teaching. The subject is mathematics. The topic is coordinate geometry, like I've said, behavioral objectives. At the end of this teaching, the students should be able to know the Cartesian coordinate plane. The students should know that every point on the plane is defined by its coordinates. The students should also know the distance between 2 points on the plane. The students should also know the midpoint of a line that joins 2 points. The students should also know division of a line in a given ratio, either internal or external division. The students should also know the gradient of a line. They should also know the angle between two intersecting lines. They should also know the collinear points, what we call collinear points. These are the objectives. Now, let's look at the Cartesian coordinate plane. We want to define it. These are two mutually perpendicular lines that intersect at a point called the origin. Denoted by letter O. It is named after its inventor, a French mathematician called René Descartes. The vertical line is called the y-axis. The vertical line is called the y-axis, or you can call it the coordinates, while the horizontal line is called the x-axis, or we can call it abscissa. Now, I want to show the diagram of the Cartesian coordinate plane. Is on this one. We say it's two mutually perpendicular lines. So they intersect at a point called origin. Now this one is x-axis, and in this way we have the y-axis. So they intersect at this point. This is the y-axis, this is the x-axis. We will continue the divination every point on the plane is defined by its coordinates. It's what we call coordinates. For instance, if I have a point on this plane, call this point P, then I have xy. It means that the coordinate of P is this one, x, y. So that x will stand for a number in the y-axis and the x-axis, and also y will represent a number in the y-axis. Now, for instance, if I have this is 0, I have 1 here, I have 2, I have 3, 4. It will continue like that, and this side will be minus 1, minus 2, minus 3. It will continue like that. Then this side is 1, 2, 3, and it will go like that. And then this side is minus 1, minus 2, minus 3. So that is how the coordinate plane looks like. So that these two lines now divide this plane into 4 quadrants, as we have seen, into 4 quadrants. Every point is defined by its coordinates. That is where we start. Now, for instance, these points, let me show what we call coordinates. For instance, if I place a point in this place, like I place, and I call this point P, it means point P, if I trace point P, I will meet 2. And I can also trace here to meet 3. So that I will write that P has coordinates 2 and 3. You see? That's the coordinate. So that is what defines point P. Tracing it to the x-axis and then also trace it to the y-axis. So that is how the point is known based on its coordinates. So we have said that every point on the plane is defined by its coordinates. It's very important. And so now, for example, locate the following points on the plane, or on the Cartesian coordinate plane. Have point X will have coordinate 2 and minus 4. I have another point, coordinate point R, it has minus 3 and 1. I have 3, another point here, point Q. Point Q has 1 and minus 2. So we want to locate these points on the plane. Now, let's go back to the plane again and see how we can locate point X. Point X, which has coordinate 2 and minus 4. It means 2 and minus 4. And now look at it. I will put minus 4 this way. So this is where the points will correspond. If I trace to this place, then I also trace to here. So this is the coordinate of X. So X has a coordinate 2 and what? Minus 4. So that is what we call coordinates. Again, for point R, which is minus 3 and 1. For point R is minus 3 and 1. Note that this first entry is for X axis, Y, this one is for Y axis. And so, in that way, I will place the point somewhere here. Will be here. Why is it here? Because x is minus 3 and then y is 1. So if I place from here to this place, I will get my point. Then I place it here. So this is where the point for. So I can now see that R has coordinate minus 3 and 1. Now let's look at the third point, which is Q. And Q has coordinate 1 and minus 2. So 1 is for x, minus 2 is for y. 1 and minus 2 for y. So that one, if I place 1 from x axis, I will reach this point, then minus 2 from here. So this particular point is point Q, which is defined by its coordinates 1 and minus 2. So these are the ways that we can locate points on the plane. It's very simple to locate. So you can see and agree that every point on the plane is defined based on its coordinates. It's very, very clear that it's defined based on its coordinates. So now we are going to look at the next subtopic, and we are going to look at the distance between 2 points on the plane. So we are looking at distance between 2 points on the plane. Now consider this plane, this Cartesian coordinate plane, where you know that this is the x-axis and this is the y-axis. Now, if I have a point here, and I also have another point, say here, let me shift the points. I have 2 points now. I have 2 points. So, these points here, if I join these points to this one, we know that to get the gradient of this point, then I can pick another line here. So this is point. Let me call this point P and call this one point R. But don't forget that point R has coordinates in y, and here it also has to this side. But this is y-axis. So if I have here y1, I have here y2. Same thing will happen to this way. So that I have here x2 and I have here x1. Because from this line, if I go this way, then this first one will also have coordinate corresponding to x-axis, and will also have coordinate corresponding to y-axis. So let me call that one y1 and call it x1. Then at this point, I will call it x2 and also have its coordinate y2. Now, this particular distance from here is the same as y2 minus y1, because if I minus y2 from here, then I will have this distance. And this distance here is the same thing as this distance here. Same thing happened here. This one is the same as x2 minus x1. And so this one, let me represent this by r. But one thing is sure here, that I have a right angle triangle. Then by Pythagoras theorem, which you know, suppose I call this place. Let me call this place. I have P, R, let me call it Q. We know that PQ squared plus RQ squared will be equal to PR squared. By Pythagoras, PQ squared plus RQ squared will be equal to PR squared. And so, PQ is equal to S2 minus S1. That is what P cube is. Look at it. This is the same thing as here. And that we also know that R cube is the same as y2 minus y1. We are representing it there. And then R, we have P R as this is the same thing as R. So let's go back to this list. We can then write it this way, that P cube squared, which is this, that x2 minus x1 squared, since x2 minus x1 is equal to B cube, which we have seen here, which is here too, plus, is this plus, R cube. And what is R cube? R cube is y2 minus y1 squared will be equal to PR squared. And what is PR? PR is R, so we have R squared. Remember, what we are looking for is this distance, which is represented by R. So, I can write it this way, that R squared is equal to x2 minus x1 squared plus y2 minus y1 squared. Now, for me to get R, because I need R, then R will be equal to x2 minus x1 squared plus y2 minus y1 squared inside the square root. So the distance between 2 points is given by this square root of x2 minus x1 squared plus y2 minus y1 squared. So you can get the distance between any 2 points on the plane using this formula. Now let's take example and see how you can apply it. We are going to find the distance between the points. Point A has coordinates 2 and 3, and another point B, which has coordinates 5 and 7. Now, the solution. We know that we let the distance between point A and B be R. You can use any other letter, not that it must be R. But we are taking R now to be the distance, and that R will be equal to square root of x2 minus x1 squared plus y2 minus y1 squared. But we know that x2 is equal to 5, x1 is equal to 2. You know, this is the first point. So everything here will be x1, y1, and this one will be x2, y2. So x2 is 5, x1 is 2. Now what about y2? y2 is 7, and then y1 is what? 3. Now we will just substitute this in this formula. If we do that, we now have that y will be equal to square root of x2 here is 5, so 5 minus x1, which is 2, square plus y2 is 7, minus y1, which is 3, square. Then what do we have? We will have here 3 square, or 5 minus 3 is 3, plus 4 square, which is the same thing as 9 plus 16, because 3 square is 9, then we have 16. And so this further gives us square root of 25, which is what? 5. So the distance is 5 meters, if it is in meters that they are taking, or if it is centimeters, whatever it is. Yes, meters. So it's 5 meters. That is the distance between this point. But if we want to put this point on coordinates, you can put the point on coordinates so that you really understand that distance how it is. For instance, I want to present this point on coordinates. I think I will have something like this. I have 1, 2, 3, 4, 5, and it continues that way. You see, this thing, this 1, 2, 3 that I'm writing, it can be any other number based on scale, based on a given scale. But here, I just choose to take one unit. So this way, of course, we don't have negative in our points. So let me go this way. For the y-axis, I will have 1, 2, 3, 4, 5, 6, 7 as y-axis. So it means this point, for the first one, we have 2 for x here, plus correspond here and here, and then we have 2 for x and 3 for y-axis. Here, 2 for x, and then 3 for y-axis. Then we have this one. Now the next one is 5 for x, and then 7 for y-axis. So that means that one is somewhere here, which we can trace down to get 5, and then we trace down to get this. Now if I join these points, you see from here to here is what I have. And then you can see how y2, you know this one, if I start from here, the first point I have here is y1, the second one is y2. So you can see how we use y2 and minus y1, that is how you see here, which corresponds to our proof that we prove here. So we can now get the distance, which is this 5 minus 3, and this one is 7 minus 3. Then by Pythagoras theorem, we can square it and get the distance. So the distance between 2 points is given by this formula. So it's very simple to understand. The next subtopic we are going to look at is coordinate of midpoints of a line. Now, consider the plane, Cartesian coordinate plane again. Everything we are going to do in this course will deal with the plane. Now suppose I have a point here, and I have another point here. If I join these points to this one, no one I have a straight line. Then my interest is, how will I know the middle of this straight line, the midpoint there, and what are the coordinates of these midpoints? I cannot just assume, okay, here may be the middle, or here may be the middle. But I have a formula that I can really know the midpoint. Now what I will do is, let me join here with this place. Let this point be point P, and in point P, I will have coordinates x1 and y1. Now let me take a variable point, which is xr and then yr. This is point r. Now I have another point, call this place point Q, and I have x2 and y2 in point Q. Okay, so you see here I'm joining this to that variable point, so I have something like this. Now for me to get these coordinates, what I will do is xr minus x1. This xr the distance from this place, SR minus S1, you know, this distance, this coordinate minus this coordinate will always give us the distance. So SR minus S1 will be the same. It will be the same as S2 minus SR. It is the same as S2 minus SR. So if it is so, then I will have SR, I'll collect like terms, then I bring SR this way, plus SR will be equal to S2 plus S1. You know, I'm transferring S1 from here to this side. So because it was negative here, we turn to positive. And this one SR, I come in this way, we turn to positive. So what do you observe? I have 2SR, which is equal to S2 plus S1. Now, remember that we need SR. So SR will be equal to S2 plus S1 all over 2. Now, this is the coordinate of the midpoint in R. Similarly, to get YR, then it will be the same as YR will be equal to Y2 plus Y1 all over 2. So we can now use it to get the two coordinates. The coordinates, I mean, yes, the coordinates of point R, which is the midpoint of this line. Now let's take an example on this and see how we can use this particular formula to get the coordinate of midpoints. Let's take this example. We are going to find the coordinate of the midpoint of the line joining these points. We have point X and Y. We also have point A and B. And let's take the solution. Now, we want to let the midpoint be R, so that I will have its coordinate Rx, XR, and then YR. Now, it means the coordinate of R will be S2 plus S1 all over 2. Then we have Y2 plus Y1 all over 2. These are the coordinates. So now, for the first one, that is from this A, we know that S2 is equal to 6, S1 is equal to, that is this S2, this S1. And then we also see that Y2 is equal to 8, and then Y1 is equal to 4. So you can put that. Then we will have S2, which is 2, for this S2, which is 6 plus S1, 2, all over 2. Then 8 plus 4 all over 2. So what do we have now? We have that R will be 8 plus 2 is 8, divided by 2 we have 4. So we have 4, and then this one, 8 plus 4 is 12, divided by 2 we have 6. So look at the coordinates for the midpoints. So the midpoints of X and Y is R, and its coordinates is 4 and 6. Now, I'd like you to try this using the same pattern. You have this on your own exercise. Do that. We are looking at division of the line in a given ratio. That is the next subtopic. Now, let's further get the plane. And we know that this is the y-axis. Now suppose a line divides this plane this way. I'm going to stress. But don't forget, this one we are looking at internally. So we have internal division and external division. So this one is internal division that we want to look at. So now, if I have something like this, and this is a point. Let me call this point point P. Point P has its coordinates S1 and Y1. This is point R. Point R will have SR and YR. It's a variable point. Now, I have point Q which have S2 and Y2. Then we have the ratio, which is M1, call this M2. Now, what we have here is that P R all over Q R will be equal to M1 all over M2. That is PR, or say RP. Anyway, let's take RP. RP is the same thing as PR. I know why I'm doing that. RP is the same thing as QR. Now, if it is so, what we have is that RP, to get that, we'll get SR minus S1 all over S2 minus SR. You see, I'm minusing this from this. This minus S1 all over S2 minus SR will be the same as M1 all over M2. That is this and this. Now, what it means is that if I cross multiply this thing, I will have that M2 times SR minus S1 will be equal to M1 times S2 minus SR. Because we know that is how it will go. This will times this and this will times this. Now, if I multiply this out, I'll have M2 SR minus M2 S1 will be the same as M1 S2 minus M1 SR. So, what I need now is to cross multiply. To collect items so that SR will come to his brother SR. This is M2 and then this is S2. So here we have SR. So SR will come to SR. And if we do that, we have that M1 SR plus M2 SR will be equal to M1 S2 plus M2 S1. This one is going the other way, and this one is coming this way. Now, here I can factor out SR, so that we have M1 plus M2. It is the same as M1 S2 plus M2 S1. Now, if I make SR subject of the formula, then I will have my SR will be equal to M1 S2 plus M2 S1 all over M1 plus M2. Now, this is the coordinates of the midpoint that divides a line in a given ratio. Similarly, YR will be equal to M1 Y2 plus M2 Y1 all over M1 plus M2. So, if the point is R such like what we choose here, this point will be point R, it means that the coordinates of R is given by M1 X2 plus M2 S1 all over M1 plus M2 and M1 Y2 plus M2 Y1 all over M1 plus M2. This is the coordinates of R. So let's also look at external division. This one that we have just finished is division of the line in a given ratio internally. So we also have externally. Now, external division. Let's also draw the plane, the Cartesian coordinate plane here. And this is the y-axis is x-axis. We have the origin. And suppose we have a line here, this one. We join it like this. Let's get a variable point as usual, where we have XR and coordinates and YR also. Now, I have point P. Point P has coordinates X1 and Y1. And I also have another point here, call it point Q, with coordinates X2 and Y2. Now we want to see how we can derive a formula for external division. So we have ratios also M1, M2, such that RP all over RQ will be equal to M1 all over M2. Now, what it means is that RP is here we have XR minus S1. SR minus S1 will give us RP all over RP. You see, we are starting here now. SR minus X2 will be equal to M1 all over M2. Yes. Now, if we cross multiply the same way we did for internal, we will have that M2 times SR minus X1 will be equal to M1 times SR minus X2. So if we do that, by timing this, we have that M2 SR minus M2 S1 will be equal to M1 SR minus M1 X2. So if we collect like terms, we have we have here. We have SR here. We have SR here. So we will take this to the other side, SR, so that we can also bring it to this side. Now, if we do that, see what we will have. We will have that M1 SR minus M2 SR. You know what I'm doing? I'm taking this one to that side. So you turn to minus. So I'm bringing this one now to here, so that I will have M1 S2 minus M2 S1. Like that. Here, I'm taking this one here, which is M2 SR. See, I'm taking this one to that side, but see this one is here. You know, if I take this one to this side now, then I will have M1 SR minus M2 SR. So that is what I'm putting here. There shouldn't be any confusion there. And so this one, after doing that, I'm taking here to the other side. So that is how the place goes. Now, I'm going to factor out SR. If I factor out SR, I will have M1 minus M2, which is the same as M1 S2 minus M2 S1. So to make SR subject of the formula, I will have M1 S2 minus M2 S1 all over M1 minus M2. Now, this is the coordinates of SR, the coordinate of R. That is for X coordinate we have this. Similarly, YR will be the same as M1 Y2 minus M2 Y1 all over M1 minus M2. So, we are going to take example and also see how we can apply external division and how you can get external division and internal division using this formula that we have derived. Let's take the example. Find the coordinates of the points which divides the line joining the points. Point A has coordinate minus 1, 2, and point B has coordinate 4 and minus 5. Internally, externally, in the ratio 2:3. The ratio is 2:3. So, first, we want to take the solution. Let's look at internal division. And we know if R is the point, then the coordinate of R is given by M1 S2 plus M2 S1 all over M1 plus M2, and then we have M1 Y2 plus M2 Y1 all over M1 plus M2. This will be the coordinates of R internally. This one is internally. So we are going to use this to deal with the internal division. So that means that what we will have here, we see that M1 as ratio 1 is this. Is equal to 2. M2 is equal to 3. Now, X2 is what? See, X2 is 4. Then X1 is minus 1. Then we also have Y2 is what? Minus 5. And then Y1 is 2. So we just fix this thing in this particular formula. Then we have the coordinates of that point that divide this line internally. Now, since R is the point that divides this line internally, to get the coordinate of R, we will fix this thing into the formula. So we will have that R will be M1 is 2 times S2 is minus 5 plus M2, which is 3 times S1 is minus 1 all over M1, which is 2 plus 3 as M2. Then we also have M1, which is 2 times Y2 is minus 5 plus M2, which is 3 times Y1 is 2 all over M1 2 plus 3 as M2. Now 2 times minus 5 gives us minus 10. Then we have here minus 3. Here we have minus 10. Oh, this is F2. Sorry. For F2 is 4. So we have 8. We have 8 here, minus 3. All over 5. Therefore here we have minus 10 plus 6 all over 5. 2 times minus 5 will give you minus 10. Then 3 times will give you 6. Now if we do that, here we will have 5 all over 5. That is 8 minus 3 is 5 as the coordinate. Then here we have minus 4 all over 5. Minus 10 plus 6 it was minus 4. We now see that coordinate of R be equal to 1, that is 5 minus 5 divided by 5 is 1. Then we have minus 4 all over 5. This is the coordinate of R. This is the coordinate of R. So we can also look for external division. External division. We recall that if R is the coordinate, is the point, that the coordinate of R as a point that divides the line externally is given by M1 S2 minus M2 S1 all over M1 minus M2. Now note that for external it is this minus that is the difference. Minus. Why for internal we have plus there. And then we have this one M1 Y2 minus M2 Y1 all over M1 minus M2. So if we substitute these values into this formula, then we have M1 is 2, then we have X2 is 4 minus M2 is 3, then we have X1 which is minus 1 all over 2 minus 3, that is M1 minus M2. We also have this way M1 is 2, then we have Y2 is minus 5 minus M2 is 3, then Y1 is 2. So all over 2 minus 3. Then if we multiply them, we have 8 plus 3. Why is it plus? Because minus 3 times minus 1 gives us plus 3. All over 2 minus 1 gives us minus 1. Then we also have minus 10 minus 6. 2 times minus 5 minus 10. Minus 3 times 2 minus 6. All over minus 1. So what we have here is that the coordinate of R here is 11 all over minus 1. And then we also have minus 16 all over minus 1. We can then conclude that the coordinate of R which divide these lines externally is minus 11. Then when we look at this way, minus can cancel minus. Then we have 16. So we have this line that way, minus 11 and 16, which is the coordinate of R externally. Then we have this one, 1 and minus 4 all over 5. This is the coordinate of R internally. So it's very simple to follow. Substitute the values in the formula, then you have it. Remember that for external division, minus is here in the middle. Then for external division, minus is here. While for internal, we have plus. The next subtopic, we are looking at gradients of a line. Now, consider this plane and we have a line. I have a line here. To get the gradient or slope, gradient also means slope. Now, what we mean is this is a line. How slopy is this line? I can have different lines. We want to see how slopy it is. Slope is not a big something. If I drop this chalk here, it's going to roll. So it depends the slope of this line that will make the chalk to roll very fast or very slow. So now, for me to get the gradient, to know the slope, I will take any 2 points. Let me take a point here and take a point here. Even though I take another point here or point here, any 2 points I take will give me the same gradient. So if I take a point here and also have another point here. So suppose I call this point P, I call this point R, and let me call this one point Q. Then I have Y1. If I trace this point to here, it will be Y1. And this one I will have Y2. Same thing will happen in this one. If I trace this one, then I will have X1. If I trace this one here, I will have X2. So I will let the gradient or slope, you can call it slope or we call it gradient, be M. We normally use M to represent gradients. So if it is so, for me to get gradient, it means that RQ all over PQ will be equal to M. What I mean is, this side all over here will be equal to the gradients. So, but for me to get RQ, then it must be Y2 minus Y1, which we know. And for me to get PQ, it is X2 minus X1. Therefore, gradient of the line is given by Y2 minus Y1 all over X2 minus X1. This will be equal to the gradient. Now let's take example. We are going to find the gradient of a line joining the points. The points will have point A. Point A will be 3 and 2. And point B I will have 7 and 10. So let's get this gradient. So if I have these points, solution, the gradient n will be equal to, like I said, y2 minus y1 all over x2 minus x1. And here we know that this is our x1 and this is y1. That this is x2 and this is y2. So what it means is that y2, which is 10, minus y1 is 2, all over x2, which is 7, minus x1 is 3. We will have the gradients. So this will give us 8 all over 4 will be equal to n. So n is what? 2. The gradient of that line is 2. So that is how we can get the gradient. Now, the next subtopic we want to take is what we call angle of slope. You know, we have said that the slope is got by this formula. So how can we get angle of slope? The angle of slope is the angle that a straight line makes with the positive x. So we are going to look at that. So we are looking at angle of slope, and we have said that the angle which a straight line makes with the positive direction of x is called angle of slope. Now let's consider this Cartesian plane. Suppose we have a line, and then we know that for any 2 points in this line, and the gradient now we can do this to take the gradients, which this line corresponds to y1, and we know that this one corresponds to y2. Same thing happens here when we have x1, and this one is x2. But there is angle here, and we should not forget that this line here is the same thing with y-axis, so we can be sent here by y, and this one is x. So what do we observe? We are considering this angle theta. So now that angle theta, tan theta, we say tan theta is equal to y all over x. How? Because this is opposite. Now this is right angle triangle. So this is opposite all over adjacent. This is adjacent to this theta, and this is opposite. Y here is the hypotenuse. So opposite all over adjacent will give us tan theta. And we also see at the same time that tan theta, which is equal to y over x, will also be equal to y2 minus y1 all over x2 minus x1. So what it means is that tan theta is the same thing as the gradient. So if we get the gradient, we can also get tan theta, the angle theta, from the gradient. Now we are going to take example on this. But before we do that, we have to note that if tan theta is 0, if the gradient is 0, it means that the line is parallel. It means that the line is parallel. But if tan theta is 90 degrees, it means that this line is perpendicular That is, you will have a line like this. It must be perpendicular where you form 90 degrees. Now, if the line is acute, what we call acute angle, if the angle is acute angle, it means that tan theta will be positive. The gradient will also be positive. But if the angle is obtuse, that is above 90 degrees, it means tan theta will be negative. So these are things we must know about this angle. And so we have to take example to see how we can get the angle of slope from the gradients. Let's take example. Now let's look at this example. Find the gradient and angle of slope of the straight line joining the points point P, the coordinate -3, 2, and point Q, the coordinate 5 and 5. Solution. The first thing we want to get is the gradient. So let M be the gradient. Then we know that y2 minus y1 all over s2 minus s1 will be equal to the gradient M. Now here y2 is 5, y1 is 2. So we say 5 minus 2 all over 5, that is s2 minus s1 minus 3 will be equal to n, which is the gradient. So here, what we have here is 3 all over. The minus times minus 3 will give us plus. So what we have is 8. So it means that we have that n, that is the gradient, is equal to 3 all over 8. Now the next thing that we want to get here is the angle of slope, because we say we should find the gradient and angle of slope. So how do we get the angle of slope? We know that tan theta is equal to m. Tan theta is equal to the gradient. So that means tan theta will be equal to 3 all over 8. So now 3 divided by 8 give us tan theta will be equal to 0.375. Now if we take inverse of this, as press shift and press time have inverse, you will have that tan theta inverse of this will give us that theta is equal to 20.5 degrees. So that is the angle that these two lines, these 2 points met with the positive direction of x, which is the angle of slope. We are looking at angle between 2 intersecting lines. Now let's consider 2 lines intersecting each other point on the plane. Suppose we have 2 lines in this way, and then this line make angle theta here. We will call this one theta 1, and then we have another one here. Call this one theta 2. If we are looking at this angle between 2 intersecting lines, don't forget that theta here, we also have theta here, they are equal. That is angle, 2 opposite angle. But we want to see how we can get this angle. And we know very well that theta 2 is the same as theta 1 plus theta. External angle is opposite to two internal angles. When we have two internal angles like this, it is equal, it's equal to this external angle. External angle is equal to two opposite internal angles. Now, what it means is that for us to get theta, then theta will be equal to theta 2 minus theta 1. What I'm doing is that I'm transferring this to this way. So to get theta, then theta will be equal to theta 2 minus theta 1, which is what I'm putting down. But we know very well that theta is the same, tan theta. That theta is tan. Theta is tan. And so we can say that tan theta is equal to tan theta 2 minus tan theta 1. We just finished angle of slope, and we see how theta is the same with the slope. Now, we can also write it as tan theta 2 minus tan theta 1. I'm factoring out tan. So we have something like this, theta 2 minus theta 1. If I time this with this, I'll get back this. Time this with this, I'll get back this. So as it is, we see that tan theta will be the same as m2 minus m1 all over 1 plus m2 minus m2 m1. So how do we know? Because formally what we have from here, we should know from here that even theta 2 is the same as tan theta 2 minus tan theta 1. Let me start here first so that you understand. And I will have here tan theta 2 tan theta 1. Why do we have it this way? Although it's a long story, we are going to touch it a little so you understand. In trigonometry, if you have watched our lectures on trigonometry, when we talk about compound angles, we said, I'm going to demonstrate here. We said that sine theta, maybe sine A plus B, let me put that, sine A plus B is the same thing as sine A cos B plus sine cos A sine B. And also when we have sine A minus B, then we will have sine A cos B minus cos A sine B. Now you are going to watch the proof when you look at our lectures on trigonometry. You get the proof how we get sine A plus B, which is equal to this. Now, but for the sake of clarifying this particular place, we want to just call back this particular identity in trigonometry, and we see that if we have cos A plus B, it will be the same as cos A cos B minus sin A sin B. And if we have cos A minus B, then we will have cos A cos B plus sin A sin B. Now, for tan A minus B, what do we have? We know very well that tan is equal to sine all over cos. So we can say that tan A minus B is the same as sine A minus B all over cos A minus B. So this will give us sine. But we know also that sine A minus B is the same. Look at it. So we have it is same as sine A cos B minus cos A sine B over cos A minus B, which is also cos A minus B. We have here cos A cos B plus sine A sine B. So tan A minus B is equal to this. Now, if it is so, we are going to divide dividing through by cos A cos B. We divide the up and the down by cos A cos B. We will have something like this, that tan A minus B is the same as sine A cos B minus cos A sine B, which is this one, divided by cos A cos B cos A cos B all over. We have divided this one, so we want to divide this one also. Cos A cos B plus sine A sine B all over cos A cos B cos A cos B. We are dividing the up and the down by cos A cos B. See, we divide the up cos A cos B divided down. Now when you do this, you see that you have that this can cancel this, and we also have cos A here cancelling cos A. Now this is cos A cos B and this is cos A cos B. So the whole thing here can cancel. Now what we have here is sine A all over cos A minus, see this one cancel this one, we have sine B all over cos B all over. Since here and here they are the same, so we have 1 plus, now sine A cos A, we have sine A sine B all over cos A cos B. But I want to believe we know that sine A cos A is the same as tan A minus sine B cos B will be the same as tan B all over 1 plus, now look at this, sine A cos A is the same thing as tan A. Sine B cos B is the same thing as tan B. Now what do we have here? We have tan A minus tan B all over 1 plus tan A tan B. So that is tan A minus B. Now relate this to what we have here. We have here tan theta 2 minus theta 1. So it's just the same thing as saying A minus B, just as we have tan A minus B. Because there are two different angles here, A and B. So here they are different, 2 and 1. So tan, anytime we have tan 2 or tan A minus tan B, then it will be the same thing as having tan A minus tan B all over 1 plus tan A tan B. You can see the proof. So here, that's why I just replaced this thing, I just replace tan theta 2 minus tan theta 1 all over 1 plus tan theta 2 tan theta 1. So we can also know that tan is the same as the gradient, so I can replace it now by m2 minus m1 all over 1 plus m2 m1. So tan theta will be the same as m2 minus m1 all over 1 plus m2 m1. And we should also know that m is the gradient. So if we have two lines intersecting, for us to get the angle, we will find the gradient of the other line, call that one m1, find the gradient of another line, which is m2. If you get these two gradients, then for you to get theta, replace it by this. And there are very important points that we will note, that if tan theta is positive, if tan theta if this tan is negative, it means we will have obtuse angle, we should remember. And then when it is positive, it means we have acute angle. Now, we want to look at example. Let's take one example that will make us understand this particular topic. And apart from that, we also know that this m2 is gradient of a line, call that one line 2, m1 another gradient. So if we join it together, we get theta. Now we look at these lines. If it is parallel and if it is perpendicular, what will happen? Let's look at number 1. We call it condition for parallel line. Condition for parallel lines. For this line to be parallel, if we have two lines and we say it's parallel, it means the gradient is 0 and the angle is 0, which we have already said it. So what it means is that m2 minus m1 all over 1 plus m2 m1 will be equal to 0. Of course, 0 over 1 is 0. So now, if I cross multiply this thing, if I cross multiply this thing here and here to here, what will I have? I will have m2 minus m1. Look at that. Because this will times 3. So this also times here. It becomes 0. So it will be equal to 0. Meaning that m2 will be equal to m1 if I transfer this one. Condition for parallel perpendicular lines. Now, for any two lines to be perpendicular, it means they must make angle 90 degrees. That means when we say perpendicular, it must be in this way, where we have angle 90 degrees. The angle must be 90 degrees. Right? What we mean is that tan theta will be equal to, which is equal to m2 minus m1 all over 1 plus m2 m1 will be equal to 90 degrees. But we know very well that tan 90 degrees is undefined. And for this particular expression here to be undefined, what will happen? It means the denominator must be equal to 0. So that if I have m2 minus m1 all over 1 plus m2 m1 will be equal to 0. the that side will be equal to 0. That is 1 plus m2 m1 will be equal to 0. So m2 m1 will be equal to minus 1. Now what we observe is that for any two lines to be perpendicular, the gradient of the two lines, the product of the gradients of the two lines must be equal to minus 1. So if we multiply the gradient and we have minus 1, then we can conclude that the lines are perpendicular. And we should also know that for parallel, if the gradient of one line is equal to the other, then we'll say that they are parallel. Alright, now let's take some examples how we can apply these things. Now, for this example, we are going to determine whether PQ is parallel or perpendicular to XY in each of the following. For A, we have P, point P with this coordinate, Q with this coordinate, X and Y with these coordinates. The same thing happens to B. And let's take the solution. So, the solution, I'm going to first take the gradients of these two points. Gradients of PQ is 3, that is x, y2 minus y1. 3 minus 1 all over x2, which is 4 minus 1. y2 is 3 minus y1 is 1 all over s2, which is 4 minus s1. s1 is 3. So we will have 2 all over 1, which is 2. Now, that is gradient of PQ. We also take gradient of XY. Gradient of XY, we have y2, which is 8, minus y1, which is 6, all over s2 is 5, s2 is 5, all over s1, which is 4, minus 4. So we have 2 all over 1, which is also 2. Now here, if the gradient of PQ is M2 or M1 and the gradient of SP is M2, now we have seen that M1 is equal to M2. They have two gradients, the same. So in this way, we can say that this particular lines, they are parallel, because when the gradients are the same, we will say that they are parallel. Now let's also investigate for B. For that one, gradients of PQ. Here is P and this is Q. So we have minus 3, that's for y2, minus 3 minus 2, that is y1, all over x2, which is 2 minus 1. So here we will have 3 minus 3 plus 2 all over 3. So this times this will give us 1, that is plus 1. So we have 3. Now this will be the same as what? Minus 1 all over 3. That's the gradient. Now gradient of xy. Xy is this one, this and this. Remember that this is the point, this is the point. So if I join this is a line. I have line here, I have line here. So I've taken gradient of this one, I have minus 1 all over 3. I'm taking the gradient of this one. So the gradient of x, point x and y will be y2, which is 7, minus y1, which is 4, all over x2, which is 6, minus x1, which is 5. So I will have 3 all over 1, which is equal to 3. Now, I have seen that the gradient of this one is not equal to gradient of this one. So, for me to investigate whether they are perpendicular, we have seen that m1 or m2 times m1, that is m1 m2, must be equal to minus 1. If it is equal to minus 1, then we will conclude that they are perpendicular. Therefore, m2 m1 will be minus 1 all over 3 times 3. Of course, this will give us minus 3 all over 3, which is minus 1. So now we can conclude that these lines are perpendicular to each other. They are perpendicular. If we plot this line on the plane, we will have it in perpendicular form. So these are the ways we can know parallel lines and the perpendicular lines. The next subtopic we are taking is equation of a line. Now, this is the relationship between the coordinates of x and y of any variable points. If we take any points and we have the coordinate x and y, and the relationship that exists, that is the equation of a line. Now we are going to take the equation of a line in different forms. First one we are going to take the gradient intercept form. One we call gradient intercept form. Now consider this plane where we have the x-axis and we have the y-axis. If I have a line here and it cuts these points, let me call this point C. But I know very well that this is my y-axis. This is x. So if I take any point at this point here, I know that this place is y minus c. This y minus c will give me the distance from here, from this particular place. Let me pick this y here. So y minus this c will give me the distance here. And that this way I have x corresponding to here. But I also know that y minus c all over x will give me the gradient, because anytime we take gradient, we will take it this way. So what it means is that m will be equal to y minus c all over x. Now if I cross multiply, I will have y minus c will be equal to mx. This is what I will have. I cross multiply this, times this with this, times this with this. You know, this is over 1. So if I times it with 1, I will still get this. Times this with this, I will get mx. That means that y will be equal to mx plus c. Now this one is called equation of a line in gradient intercept form. This one is gradient intercept form. So that if I am given a problem to solve, maybe like here, we say find Find the equation of a line whose gradient is 3 and chords and has intercept or chord the y axis at 5. What we mean is that the gradient will be 3, then you will cut y axis at 5. So the solution will be, I will know that equation of a line in gradient and intercepts, that is two things that are given me here, is given as y is equal to mx plus c. So substituting these values, your gradient is 3, the intercept is 5, then we have y is equal to 3. 3 is taking the place of x plus c. You know, c is where it cuts the y-axis from here, where we represent by c. So when we hear about cut or intercepts, point c. So we will now substitute this 5. Now if we do that, what we will have is y is equal to 3x plus 5. So it becomes the equation. Now we have formed the equation of a line with gradient 3 and it has intercepts of 5. So we'll also look at another form because we have different forms of equation of a line. And this time we are going to take gradient and 1 point form. Now consider this where we have a line. We have a line line P, this is P. Or let me take a point, I have point Q here. Then I have coordinate x1, y1. This is point P. I have point R, where I have x and y. So line PR, R has this coordinate and it passes through point Q. Now, if I take the gradient of this, we know that gradient will be x minus y, no, when I say y2, so this is point 2, it's a variable point. So this y minus y1, no, I call this one y1, all over x minus x1 will be equal to m, will be equal to gradient, which we really know. And so, if it is so, for me to cross multiply this, I will have y minus y1 will be equal to m x minus x1. This particular one is called equation of a line in gradient and 1 point form. Remember, we have derived 2 equations of a line and 2 forms. The first one was gradient and intercept form. So this one we have gradient and 1 point form. So we will also take example of questions that we can give, which we are going to apply this particular form. And let's look at this example that has to find the equation of a line of slope 2 if it passes through the point that has coordinates 3 and minus 2. Now, the solution. We know that the gradient of a line in gradient and 1 point form, the equation of a line in gradient and 1 point form is given by y minus y1 is equal to m times x minus x1. So here, m is equal to 2, that is the gradient. And then we have y1 is equal to minus 2. And then x1 is equal to 3. So we just fix this in here, in this particular equation. Then we will have the equation of the line that we need. So y minus y1, y1 is minus 2, will be equal to m is 2, bracket x, minus x1, x1 is 3. So what we will have here is y plus 2, because minus and minus will give you plus 2. Then we have 2x minus 6, like this times this, and 2 times minus 3. So y will be equal to 2x minus 6 minus 2. We are transferring this to the other side. So we have y is equal to 2x minus 8. This is the required equation of the line that we are asked to find. So when they are giving us 1 point and the gradient, we will use this particular method of equation of a line, and we'll get the right equation. So we are looking at gradient and 2 points form. Now consider this plane also, where we have y-axis and x, and we have a line like this, where we have a point. That point here, and this point is x1, that's coordinate x1 and y1. So we have another point. We take a variable point, maybe point q, which are x and y. There is another point again, call this one point b, which has x2 and y2. Now we know very well that the gradient of AQ is given as y minus y1 all over x minus x1. If we take the gradient from this place, then it will be this y minus y1 all over x minus x1. So gradient can write that gradient of AQ is equal to this. Now let's also look at gradient of QB. This one, we know that will be equal to y2 minus y1. See, we are taking AB. Sorry, let's take AB, this and this. You know, gradient of this and this is the same as gradient of this and this, because gradient at any 2 points on the line is the same. So we have y2 minus y1 all over x2 minus x1. Yes. And so for us to form a line, equation of a line that passes through 2 points, it means this one, y minus y1 all over x minus x1 will be equal to this one, y2 minus y1 all over x2 minus x1. So with this, we can now cross multiply to get the equation of the line. That's how simple it is. But apart from that, we will take example. let's see how we can use this and form a line. Using this gradient and this gradient, and we form a line. Now, we are going to find the equation of a line which passes through the points A will have 2 and 4, and point B will have 5 and minus 3. So we will now substitute this in the equation of the line, which is we have y minus y1 all over x minus x1 will be equal to y2 minus y1 all over x2 minus x1. Now here, this is the first point, and we have the second point. So x1 is 2, x2 is 5, y1 is 4, y2 is minus 3. So if we do that, we will have y minus y1, y1 is 4, all over x minus x1, which is 2, will be equal to y2, which is minus 3, minus y1, y1 is 4, all over x2, which is 5, minus x1, which is 2. So that will give us y minus 4 all over x minus 2, which is minus 7 all over 3. And then at this particular point, we can now have 3y minus 4 will be equal to minus 7x minus 2. So the line will give us minus 12, then plus times this we have minus 7x plus 14, which further simplifies to 3y will be equal to minus 7x plus 14 plus 12. That will give us 3y will be equal to minus 7x, then this one we have plus 26. So that we will have we will have y is equal to minus 7x plus 26 all over 3. We can keep it in this way, or we can keep it in this way. I'll say the same thing. So these are the way we can form equation of a line passing through 2 points.